विज्ञान तंत्रज्ञानामुळे मानव जीवन अधिक प्रगत व ज्ञानसमृद्ध. डॉक्टर ज्ञानदेव म्हस्के. मानवजातीच्या प्रगतीच्या प्रवासात मटेरियल सायन्स आणि विज्ञान तंत्रज्ञानाचे मोठे योगदान आहे. औद्योगिक क्रांतीची सुरुवात वाफेच्या शोधाने झाली आणि उत्पादन व वाहतूक क्षेत्रात मोठा बदल घडून आला. त्यानंतर जैविक ऊर्जेचा वापर आणि विजेच्या शोधामुळे मानवी जीवन अधिक गतिमान झाले. पुढे इलेक्ट्रॉनिक्सच्या शोधाने संप्रेषण व यांत्रिकी क्षेत्रात मोठी क्रांती घडली. 1963च्या सुमारास संगणकाच्या विकासामुळे डिजिटल विज्ञानाची सुरुवात झाली आणि संगणकाच्या माहिती प्रक्रिया करण्याच्या क्षमतेमध्ये मोठी वाढ झाली. यामुळे ज्ञानाच्या कक्षा अधिक विस्तारल्या. आज मटेरियल सायन्सच्या साहाय्याने फायबर व नॅनो पार्टिकल सारख्या अत्याधुनिक पदार्थाची निर्मिती होत असून आरोग्य, उद्योग, संप्रेषण व संशोधन क्षेत्रात त्याचा प्रभावी वापर होत असल्याचे प्रतिपादन कर्मवीर भाऊराव पाटील विद्यापीठ सातारा येथील कुलगुरू डॉक्टर ज्ञानदेव म्हस्के यांनी केले. रयत शिक्षण संस्था संचलित श्री सद्गुरू गंगागीर महाराज सायन्स, गौतम आर्ट्स आणि संजीवनी कॉमर्स महाविद्यालय कोपरगाव येथे विज्ञान व तंत्रज्ञान क्षेत्रातील अत्याधुनिक संशोधन व नवोपक्रमांतर्गत आधारित 2026 ही 2 दिवसीय आंतरराष्ट्रीय कार्यशाळेचे उद्घाटन कर्मवीर भाऊराव पाटील विद्यापीठ सातारा येथील कुलगुरू ज्ञानदेव म्हस्के यांच्या हस्ते झाले. प्रमुख अतिथी म्हणून स्वामी रामानंद तीर्थ मराठवाडा विद्यापीठ नांदेडचे माजी कुलगुरू डॉक्टर पंडित विद्यासागर हे उपस्थित होते. कुलगुरू पंडित विद्यासागर यांनी उच्च शिक्षणाचे महत्त्व स्पष्ट करताना सांगितले की उच्च शिक्षण आणि विद्यार्थ्यांच्या भविष्यात सुरक्षित दिशा देण्याबरोबरच त्यांच्यात संशोधनाची आवड निर्माण करते आणि नवनवीन ज्ञान कौशल्य आत्मसात करण्याची क्षमता विकसित करते. तसेच यावेळेस व्यवस्थापन, स्वयं अनुशासन, जटिल ज्ञान समजून घेण्याची क्षमता आणि नव्या तंत्रज्ञानाच्या विकासात योगदान देण्याची वृत्ती विद्यार्थ्यांमध्ये विकसित होऊन माइंड म्हणजे विचार, जाणीव, कल्पनाशक्ती, आकलन, बुद्धिमत्ता, निर्णय क्षमता आणि स्मरणशक्ती यांचा समुच्चय असल्याचेही त्यांनी स्पष्ट केले आहे. शिक्षणाचा मुख्य उद्देश विद्यार्थ्यांचा सर्वांगीण विकास साधणे होय. लर्निंग टू नाव, लर्निंग टू डू आणि लर्निंग टू लिव्ह टुगेदर या तत्वावर आधारित शिक्षण व्यवस्था समाज निर्मिती महत्वाची भूमिका बजावते असे त्यांनी नमूद केले आहे. महाविद्यालयाचे प्राचार्य डॉक्टर माधव सरोदे यांनी कार्यशाळेचे प्रास्ताविक करत असताना परिषदेचा उद्देश विज्ञान तंत्रज्ञान क्षेत्रातील नव्या संशोधनाला चालना देणे व विद्यार्थ्यांमध्ये वैज्ञानिक दृष्टिकोन विकसित करणे हा असल्याचे स्पष्ट केले. तर पाहुण्यांचा परिचय अंतर्गत गुणवत्ता हमी कक्षाचे समन्वयक डॉक्टर निलेश मालपुरे यांनी करून दिला. सदर कार्यशाळेच्या उद्घाटन प्रसंगी प्राचार्य डॉक्टर दीनानाथ पाटील, माननीय प्रांजळ चित्ते नाशिक, माननीय श्री संतोष शिंदे कोल्हापूर, माननीय डॉक्टर सचिन रौंदिया बेंगलोर, डॉक्टर कृतिक PS बेंगलोर, माननीय श्री पराग मोरे मुंबई, माननीय डॉक्टर सुभाष बेंद्रे जळगाव यांच्यासह विषय तज्ज्ञ व अभ्यासक विद्यार्थी मोठ्या संख्येने उपस्थित होते. या सदर कार्यक्रमाचे सूत्रसंचालन प्राध्यापिका चेतना काळे व प्राध्यापिका प्रियंका पवार व प्राध्यापिका श्रुती पाटील यांनी केले. तर आभार विज्ञान शाखेचे उपप्राचार्य घनश्याम भगत यांनी मानले होते.
He has continued that till now, and I am very happy that now he is the Vice Chancellor, and I am sure that under his leadership the university will flourish. Another friend, Dr. Madhavrao Sarode, we had been together going for a walk in the morning, and the book which I have written, Sandanwat, of course, some portion is devoted to him also, because we had long association. See, it is very heartening when you listen good words from your colleagues, from your students. So my advice to you will be keep on doing good work. When you have no botheration about promotion, money, nothing else, and when you hear some good words, that is the best reward. Now, on this background or with this introduction, let me come to the subject. Of course, my job has been made easy by Dr. Muske because he has beautifully elaborated the subject. And actually, he has explained the concept of cutting edge so well that I don't need to stress on that. So that will give me more time to discuss that what are the actual problems and how do we approach to that problem. My theme is that when we are talking about cutting edge or cutting edge research, what is it? How do we define it? Next. What is cutting edge technology? The most advanced, pioneering and innovative. It has to be. Innovation means adding value. Some value has to be added. It should not be a routine kind of a thing. Then studies should be at the forefront. Means whatever not been done. So you have to be there. So whatever is the question posed and we don't have the answer, we have to seek the answer for that question. So it should be at the forefront. Create new knowledge and breakthroughs. Like the example, very apt example was DNA structure. That was a breakthrough because that made us understand biology or biological function because there were many questions. Mendel has done many experiments and he has showed that how genetic transformation takes place. But there was no explanation how does it happen, and that's why his work was not recognized. But when we got this structure of DNA, everything became easy. So it was a breakthrough. Pushes limits of current understanding. So whatever is current understanding, we go one step ahead. So that is another thing. Highly impactful means its impact is felt all over the world, not only in a particular area or particular region or particular community, but it is overall impact and solve complex problems. It is not an easy problem which is being solved. Complex, which is very difficult, and people are not able to get the answer for that. If you can get that answer, then of course it becomes a cutting edge research. Now, how to succeed? The students are here, so they have to prepare for these kind of challenges. Of course, many students will be doing research or they will be taking up that as a career. But if you want to be a scientist at the cutting edge, then we have to proceed, and there is a role for higher education to play also. So we'll see that what is required. The first is creating an environment. Unless there is an environment, you don't think in that direction. If there is a mediocre kind of a thing which are happening around you, you are expected to fall in that, and you will also continue with the same notion. So this should not happen. But for that you need capacity. You can imagine many things. I can imagine I can do this, I can do that. But do I have that capacity? Suppose I want to write a book. Do I have the capacity to write a book? So I have to develop that capacity. Or if I am doing research, then I have to develop the capacity. If I am giving a lecture, I have to develop a capacity. So capacity building is very important. And for that, you need holistic development. Many times now there is a implementation of NEP is going on. And as I go around, there are many sort of complaints, or you can say that people are facing difficulties in implementing. Most difficulty people face that they say that if you are doing holistic development, then student is jack of all trades, master of none. That is one way of doing it. Second thing, there is another complaint that the core content of the subject is reduced. So he is not as good as he was earlier, like a student in physics or biology or zoology or botany or mathematics. So these are the questions which we have to face. But I have seen examples. Just recently I was there in one college, it's Kaveri College in Pune. And there I saw that they have implemented this NEP in such a way that students are doing so well in other areas along with the academics. And one example I can give you, a student in FY Commerce has already cleared the subject for CA. Plus he has got high CGPA in the regular examination. So this one example, there are many examples like that. So we have to understand the concept and implement it. When you say that core content is reduced, how can you accommodate it in other subjects? That you will have to see. You will have to reorient your teaching learning methods. Implementing NEP with the old methods is not of any use because you will not be successful. You will have to change teaching learning methods. So that is another thing which you have to take into account. Change in mindset. It's very important. Mindset is very important because mindset decides that what you will do. If your mindset is of mediocre level, then you will do mediocre things. If it is higher, you will go at the higher level. So mindset is very important. That I will explain you in short afterwards. Implementation, anything means whatever you plan, we have to implement it effectively. There, I think we are falling short because many colleges, they are not implementing NEP properly or they are not able to implement NEP properly. So that is very important. And what is the mantra? Mantra is innovation, innovation and entrepreneurship. Invention is a routine research. You can try to find out something or try to get answer for some question. Innovation means value addition. And beyond that is entrepreneurship, because if you can convert that into a entrepreneurship or entrepreneur, you become entrepreneur, then that is the real success. So we have to keep the mindset like that. We cannot. And of course, there is a role for higher education institutions in this. So what are the objectives which we have decided? Creating new system aligned with aspirational growth in 21st century. Right now, Dr. Muske has very beautifully explained that what is happening because of artificial intelligence. I need not go into that. But things are changing so fast. Yesterday, I sent invitation of my book release to one of my students in Indonesia. She did PhD with me. And of course, this was in Marathi. She returned that with an English translation of that invitation and asked that is it correct. And when I read it, it was beautiful. Then I asked her, who did it? She said, Google did it. So these are the things, they are changing very fast. So if you write Dr. Pandit Vidyasagar, Pune, they will give a beautiful biodata, which I also don't know about myself. When I read it, there were many things which I didn't know. Artificial intelligence knows it, or ChatGPT knows it. So these are the things which are happening. But you don't have to be scared about that. I will explain that later on. Learning to know is very important. So students should orient themselves that you are learning to know. Learning to remember, no. You are not learning to remember. You are learning to know. So understand it properly. Learning to live together towards holistic. And what is holistic development? That there are many aspects related to that. First is, of course, you have to memorize certain things. It is not that you don't remember anything and you will do that. So memory is there. Reasoning. You should reason out. Ask questions. Whenever something is told to you or some statement is made, you have to ask questions, which generally doesn't happen. Means our students are lagging behind in that, especially rural or area students and all. They are not used to ask questions. So develop that capacity. Reason it out. Aesthetic sense. This is very important. We are lacking that. We are not trained. We are not educated in that direction. And that is the lacuna in our educational system right from the beginning. Anything looking beautiful or aesthetic. So that sense we don't have, that we have to develop. Physical capabilities are also very important. In 21st century, you should have mind, brain and body, all three. If you have only brain, it's of no use. If you have only body, it is of no use. But you should have all three. Mind also, very sound mind you must have. And these are required in 21st century. So that we should, communication skills. How to communicate, argue it out, or explain certain things to others, that they should understand it properly. So communication is very important. what higher education gives you or expected to give you. That is to ensure you to secure your future, can engage you in research, new information and skills, time management and self-discipline. Time management is very important. Many people ask me a question that how can you do so many things? Because I was administrator, I was a researcher, I was teacher, I was a writer. I also used to give lectures in the society. That is only possible if you can manage your time. How to manage the time? You do parallel processing, 2-3 tasks at the same time. If you can develop that capacity, you have ample time. Once Dr. Narlikar gave one example. He said that you take a bucket and put big stones in that. Is it filled? No, you can put small stones. Is it filled? No, you can put some sand in that. Is it filled? No, you can put some soil in that. Is it filled? No, you can put water in that. So there are gaps. So when you are doing one task, you are not utilizing total time. There are gaps which go unattended. Use those gaps to do certain things or something else. Best example is say आपली आई जशी स्वयंपाक करते ना घरी किंवा बहीण वगैरे तर त्या जे एका वेळी हँडल करतात ना सगळ्या गोष्टी दॅट इज पॅरलल प्रोसेसिंग. इकडे भाकरी आहे, इकडे काही शिजतंय, तिकडे कोणीतरी हाक मारत आहे, मुलं काहीतरी डिमांड करतायत and everything is attended properly. That is parallel processing. So we have to develop that ability. Ability to serve and develop new technology. Ability to invent, innovate and that I have told. Promote social, economical and technological change. Social awareness is very important. Our education has one lacuna, that it has isolated people from their traditions. They were brought in the school with the pretext that we will train them so that they will be able to lead their life properly. And now we realize that we cannot do that, and they have lost the thing which they would have actually acquired if they would have actually joined or were with the tradition. शेतकऱ्याच्या मुलाला शेती करता येत नाही किंवा बाकीचे कारागीर त्यांना सोनाराच्या मुलाला हे दागिने घडवता येत नाही किंवा जे काही ट्रेडिशनल स्किल्स होती ती सगळी आपण विसरून गेलोय आणि शिक्षणाने आपल्याला कुठलं स्किल दिलेलं नाही. एकेकाळी आपल्याला गरज होती की फक्त शिक्षित लोकांची गरज होती भारतासारख्या देशाला, तोपर्यंत हे ठीक होतं. आता आपण एका टप्प्यावर आलोय की ज्या ठिकाणी अशा लोकांची गरज नाही आहे, फक्त ज्यांना डिग्री आहे, लिहिता येतं, वाचता येतं नाही. ते काय करू शकतात हा प्रश्न आहे, आणि त्या प्रश्नाचं उत्तर जर आपण देऊ शकलो तर आपल्याला काही प्रॉब्लेम नाही. पण त्या प्रश्नाचं उत्तर आपल्याकडे नसेल तर मग खूप मोठा प्रश्न निर्माण होणार आहे, आणि ते दॅट विल हॅव टू सी. व्हरायटी ऑफ प्रोग्राम्स ऑर करिअर फोकस हे हायर एज्युकेशनने द्यायला पाहिजे. ते देतात आहे कॉलेजेस, ते तुम्ही त्याचा फायदा घ्या. इंटरनॅशनल अवेअरनेस, ग्लोबल. मग अशी डॉक्टर मस्के म्हणाले की नाव इट इज अ ग्लोबल विलेज. ग्रामीण शहरी वगैरे असा फरक आता खूप कमी राहिला, आणि ते आपल्याला लक्षात घेतलं पाहिजे की आपलं व्यक्तिमत्व सगळीकडे सूट व्हायला पाहिजे. ग्रामीण भागात गेला तरी सूट व्हायला पाहिजे, शहरी भागात गेला तरी सूट व्हायला पाहिजे, दुसऱ्या देशात गेला तरी सूट व्हायला पाहिजे. आणि ते कसं सूट होईल की ज्यावेळेस तुम्हाला त्याचा अवेअरनेस असेल. आता त्याचं एक उदाहरण सांगतो. पुणे विद्यापीठाने दुबईला कॅम्पस काढला. आता मी डायरेक्टर होतो, बीसीडी डायरेक्टर, त्यामुळे इन्चार्ज होतो. तिथे MBAचा कोर्स आपण काढला. त्या MBAच्या कोर्सला वेर द स्टुडंट कमिंग फ्रॉम पाकिस्तान, अफगाणिस्तान और मेनी अदर कंट्रीज. आता तिथे आपण पाकिस्तानबद्दल कसं बोलतो इथे, तसं तिथे बोलता येणार नाही. तर ते अवेअरनेस आपल्याला पाहिजे, विच विल हर्ट. इट शुड नॉट हर्ट एनीबडी. वी कॅनॉट गिव्ह द सेम एक्झाम्पल्स विच वी यूज टू गिव्ह ओव्हर हिअर. तर हे जे नॉलेज आहे ना किंवा अंडरस्टँडिंग आहे ते तुम्हाला पाहिजे, म्हणजे ग्लोबल पर्सनॅलिटी पाहिजे. नर्चरिंग ग्लोबल सिटीजन्स कमिटेड टू एथिकल व्हॅल्यूज अँड युनिटी. एथिकल व्हॅल्यूज फार इम्पॉर्टंट आहे. बऱ्याच वेळा आपल्याला असं वाटतं की चालतंय, नाही चालत. कुणी ना कोणी ऑब्झर्व करत असते अँड समवेअर यू विल बी कॉट. सो फॉलोइंग एथिकल व्हॅल्यूज इज ऑलवेज इम्पॉर्टंट आणि फायद्याचं आहे. आता माइंड म्हणजे काय असतं त्यात एक थोडक्यात तुम्हाला उदाहरण सांगतो की आपल्या ब्रेनमध्ये म्हणजे मेंदूमध्ये अनेक विचार येत असतात रॅन्डम. कधी कोणाबद्दल राग येतो आपल्याला, कधी चीड येते, कधी प्रेम वाटतं, कधी कधी असे वाटतं की दगड घ्यावा उचलावा आणि फेकावा. आपण फेकतो का? नाही. मग हे का घडतं, असं का घडत नाही? तर याचं कारण माइंडसेट आहे तुमचं की यू हॅव बीन ट्रेन्ड इन अ पर्टिक्युलर वे, यू हॅव सर्टन नोशन आणि ते तो विचार थांबवतात की नाही आपण नाही असं नाही करतायत, आपण कोणाला जाऊन थप्पड नाही मारत, असं नाही करतायत. तर हा जो माइंडसेट आहे ना हा फार महत्वाचा आहे आणि तो तुम्हाला योग्य प्रकारे नर्चर अँड नरेश करायला पाहिजे. सो इफ यू कॅन डू दॅट देन व्हॉट इज रिक्वायर्ड ओव्हर देअर, इंटेलिजन्स, जजमेंट, लँग्वेज, मेमरी, सगळ्या गोष्टींचा त्याच्यामध्ये सहभाग असतो आणि त्याच्यामुळे ह्या गोष्टी आहेत ह्या तुम्हाला लक्ष द्यायला म्हणजे यू हॅव टू अटेंड दिसते. पण त्याच्या पलीकडे जाऊन एक गोष्ट आहे जो नंतरही येईल एखादाच पॉईंट, पण मी आताच सांगतो ना, दॅट इज कॉल्ड मीन्स नॉन एक्सप्लिसिट लर्निंग. एक्सप्लिसिट लर्निंग म्हणजे काय की जी गोष्ट आपल्याला समजली आणि आपण ती सांगू शकतो. त्याचं एक उदाहरण साधं आहे की एक माणूस बाजारात जातो, तिथे एक आदिवासी मुलगी बांबूच्या टोपले विकत असते. टोपले सुंदर असतात. तर तो माणूस जातो आणि तिला विचारतो की तू मला कसं बनवायचं हे शिकवू शकते का? तर तिला काही प्रश्न कळत नाही. ती म्हणजे शिकवणं काय असतं मला नाही, मी करून दाखवतो, शिकवणं मला नाही. व्हॉट इज टू बी टॉट. तर हे का घडतं? कारण शी हॅज इम्प्लिसिट लर्निंग. इम्प्लिसिट लर्निंग म्हणजे काय तर आपण नकळत शिकतो. जसं आता सायकल चालवतो, मोटार चालवतो, स्कूटर चालवतो. आता तुम्ही निगोशिएट करता की समोरून एखादा आता तुम्ही इकडून जाता, तुम्हाला विचारलं तुम्ही कसं काय केलं ते म्हणाल नाही मला नाही माहिती पण मी केलं. दॅट इज अ व्हेरी इम्पॉर्टंट पार्ट आणि इट कम्स थ्रू एक्सपिरियन्शियल लर्निंग. ज्यावेळेस तुम्ही स्वतःच्या हाताने गोष्टी कराल त्यावेळेस ह्या गोष्टी आपोआप तुमच्या शरीरामध्ये भिनत जातात आणि बॉडी आणि माइंड हे एकत्र काम करायला लागतं. त्याचं दुसरं उदाहरण सांगतो की मी ज्यावेळेस लेख लिहितो किंवा एखादी स्टोरी लिहितो, एखादं वाक्य माझ्या डोक्यात येतं आणि मी ते लिहायला सुरुवात करतो आणि अचानक दुसरंच वाक्य लिहून जातो की जे पहिल्यापेक्षा म्हणजे माझ्या मनात जे आहे त्याच्यापेक्षा चांगलं असतं. हे कुठून आलं? वेअर फ्रॉम इट हॅज कम? आय डोंट नो. तर ती बॉडी ट्रेन झाली आहे माझी त्याच्यावर म्हणजे बॉडी इज ऑल्सो वर्किंग विथ मी, नॉट ओनली माइंड बट बॉडी ऑल्सो वर्क. आणि हे जे फ्युजन आहे ना ते फार महत्वाचं आहे आणि ते कशामुळे येतं तर ते तुमच्या इम्प्लिसिट लर्निंग मधून ते येतं आणि त्यासाठी प्रॉपर माइंडसेट पाहिजे. आणि हे सगळं कशाशी रिलेटेड आहे? ह्युमन ब्रेन. दॅट इज द बेस्ट इन्स्ट्रुमेंट विच वी हॅव अँड विच नेचर हॅज गिफ्टेड अस. वी हॅव टू यूज दिस इन्स्ट्रुमेंट. म्हणजे आर्टिफिशियल इंटेलिजन्सच्या पुढे काम करायला पाहिजे आपण. तुम्हाला माहिती आहे का सध्या तरी असं म्हटलं जातं की आर्टिफिशियल इंटेलिजन्स इज कॉन्फिडेंट बट नॉट ॲक्युरेट because it will provide you some wrong information also and you should have an ability to identify that. So you should be one step ahead of artificial intelligence or whatever is being given to you. जसं अगदी सोपं उदाहरण की माझ्या बायोडेटामध्ये त्यांनी लिहिलं की मी एमफिल पण केलंय म्हणून. ते कुठून त्याला कळलं माहित नाही, मी केलेलंच नाही एमफिल, पण इट इज देअर. सो इट इज कॉन्फिडेंटली सांगतोय तो की हे तुमचं बायोडेटा आहे म्हणून, पण इट इज नॉट ॲक्युरेट. तर ही गोष्ट तुम्हाला समजून घेतली पाहिजे अँड दॅट विल हॅपन ओनली इफ यू यूज युअर ब्रेन. ह्युमन ब्रेन इज फार सुपिरियर ॲज कम्पेअर टू अदर ॲनिमल्स. तुम्हाला माहिती आहे की आपला नियरेस्ट नेबर कोण आहे? चिंपॅन्झी. आणि चिंपॅन्झीला कप आणि मम्मा शब्द शिकायला 6 महिने लागतात. मानवी मूल 6 महिन्यात भरपूर शब्द शिकतात, तुम्हाला माहिती आहे. त्यामुळे देर आर मेनी कपॅसिटीज विच वी हॅव, वी शुड यूज इट. आय विल नॉट गो इन टू दॅट. ब्रेन मॅनेजेस ऑल दिस इन द बॉडी. त्यामुळे आर्टिफिशियल इंटेलिजन्सला घाबरायचं कारण नाही. दिस इज complicated enough to manage. Okay. आता सीट ऑफ द माइंड जे आहे ना ते हृदयात नाही आहे, ब्रेन मध्ये, हे लक्षात घ्या. म्हणजे पूर्वी असं नोशन होतं आपलं की हृदय म्हणजे मन, तसं नाही आहे. त्याचं ओरिजिन कुठे? ब्रेन मध्ये. ते पण आपण लक्षात घ्यायला. काही काही मुद्दे मी जरा रिपीट होत आहेत ते काढून टाकतो. रिसर्च, आता आपण रिसर्चवर येऊ. आपला जो टॉपिक आहे, व्हॉट आर द प्रेझेंट प्रॉब्लेम्स, नीड्स काय? क्लीन ड्रिंकिंग वॉटर अँड सॅनिटेशन. You will see that, you will think that this is a very simple problem. What is there? This is the most difficult problem, and it will become more difficult because there will be scarcity of water in coming future. You may not have it because Godavari is there, but cities like Pune have already started facing this difficulty. Quality health care and education is very important. Quality of health. If you compare our average health with the average health of US or a very developed country, then we are far behind. Individually, okay, I may be good, but when you compare all the people around me and take out the average, it is very low. Education, yes, trade is there. Accessibility has increased in last 75 years. What about quality? Quality of education is going down day by day. And maybe if this continues, quality education will not be affordable for the poor people or lower status. Because if you compare the fees paid in the government schools or in aided colleges or universities and private universities, there is no comparison. Here it is 3,000, there is 3 lakhs. So that is the disparity. So education is also a very big problem. Improved transportation and air quality. Air quality is going down. Mumbai air quality you must be seeing every day. Energy and infrastructure, that is another area of this. Automatic driving, that is going on now. Already there are, in US, there are, say, vehicles which are driven by the computers. And they take you to the destination, wherever you want to go. There is no driver. So this will come. When I went to France long back, of course they had a local train. And we got into the compartment, the first compartment. And there was no driver, nobody is seen. So one person was standing like this and looking. So we thought he is the driver. After some time, he also, climbed down. And the train was going. So that was an automatic train. It halts at the particular station and goes between 2 stations regularly. So this is also artificial intelligence has been already bionic living spaces, means it is computer human interaction. Like that some people they have handicap or amputated hand. Now we can put a chip into the hand so that it will be able to make the movements of the artificial limbs, or put the chip in the brain directly and regulate the actions from outside. So that is called the computer human interface. So that is also another area. Now to do this, you need interdisciplinary and multidisciplinary approach. Now what is it? It has been explained by Dr. Maske very well. I'll give only one example. This is a process of seeing. How do you see? So this is here that is the field, that's left visual field and right visual field. The light reflected from that comes to the eye. In the eye you have cornea, then you have lens, and then you have retina. So there is a refraction which is taking place. Reflection has already taken place. Then there is a biopotential which is generated in the rods and cones. change in biopotential. Then action potentials are generated. Then they are taken to the visual center, where and while going there is a lot of processing which is being done. And ultimately we see a image. How many subjects are involved in this? You have physics, you have chemistry, you have biology, you have mathematics, you have computer, everything is there. And suppose you ask a question, who sees it? Is there a single cell in the brain which sees it? No. We don't know who sees it. Brain sees it. That becomes a philosophical question. So many things involved in one action. What does it mean? It means that nature does not think in terms of subjects. These are the man-made boundaries, physics, chemistry, biology, all these things. So if you really want to understand anything, you will have to bring all the subjects together, apply to that problem and solve it. For example, water management. How many subjects are involved in that? There is a physics, chemistry, biology, management, social science, any subject you take, it gets involved in that. Only what is the problem? Problem is water management. So that's why we have to make our mindset or develop our mindset in that direction. Now nanotechnology we were talking about, and there are many things happening at that level. Nature has already been done this. Nature is ahead of us. Nano means what? Abjaunsh. Abjaunsh. एक abjaunsh म्हणजे 1 nanometer. So at that level, there are so many things which happen in our body or in the body of the animal. And there are many questions which are not answered yet. Though we know how it happens, but we don't know why it happens. Or can we make it happen? So there are gaps. So what we are doing, we are using the information and the processes which are already there in the nature. Like in case of Dolly, what we have done, we have not done anything. What we try to do, we try to fertilize an egg by artificially introducing the fertilization. That's what we have done. But rest of the process is done by nature, not by us. And in that case, our understanding is not perfect, so that there were many defects in the Dolly. Dolly could not survive for a long time because we have actually produced that animal in a different environment. So there are gaps, means we don't know how to do that. So there are many questions which are unanswered, though there are some results which we have got. Now like organic memory in material science, what we are trying to do, we are trying to use organic material to form a, say, transistor or field effect transistor. So that is there. And why do we need this? Because we want to make improvements in memory, displays, layers, mobile phones, laptops, tablets. The features, new features are coming. Where from they come? They come from the advancement in material science. And we are using the same to get the better and better products. There are many electronic materials which we want to develop. Organic semiconductors, electroluminescent materials, all these things are there. Now what are the applications? Why are we doing this cutting edge technology? Energy production and management. Energy is the key thing. If you define development, it means that how much energy that particular society is using. So that decides whether society is developed or not developed. So energy is an essential ingredient in our life. Without energy, we can't sustain. External or internal. Through food, we get the internal energy, ATP formation. External, we get energy for external things. And both are essential for that. So we need breakthroughs because we are using solar cells. Now conversion efficiency is the problem. We have to increase that. And how much we can increase it. More we increase, more energy will be available to us. So we need breakthrough in that. Chemicals, different types of chemicals also. Automobiles. Now automobiles are going from mechanical to electrical, and in that also there are lot many say inventions or say we need many new things to be added. Space exploration is another area. Now we have gone up to moon. Means a human being has reached to moon. But if you want to go beyond, then you will need a spaceship which will be self-sufficient. Imagine our Earth has a spaceship. Our Earth is a spaceship. It is moving in the space. Only external thing which we get is the sunlight. Other things we have to manage over here only, and they are managed. So there is a balance, there is an equilibrium. So if you want to go to other say planets or beyond the solar system, then what we need? We need a spaceship which is self-sufficient. Only sunlight you may get from outside. Rest of the things you have to manage. And that is a big challenge because Stephen Hawking has said that you can stay on this earth or human being can exist on this earth only for 100 years. If we are going in the same way to the development and depleting the natural resources, after 100 years, we have nothing to live. So that is another challenge we have to face. Defense, of course, is there. Agriculture, there are many problems. Biology and medicine. In medicine, we have, of course, we have got some success in controlling cancer or treating cancer. But there are certain diseases which we have no solution, like Alzheimer, we don't have, or Parkinson disease, we don't have solution. So there are many diseases where breakthroughs are required. Robots are developing themselves day by day. Yesterday only I have seen a film where Chinese robots, they are doing dancing, they are doing all acrobats kind of thing. So that is a challenging area. And if you read the science fiction, there are examples of a planet where there are more robots than the human being. So that may happen one day. Now, what do we learn from biological system? We can learn many things because nature has developed many things which we are not able to develop. One example only I will give. In ear, whatever we listen, there is a process which takes place. There is an eardrum, then there is a middle ear where there are three bones which are coupled. Then they transfer these vibrations to the inner ear. There is a membrane, there is a fluid, okay? And then there are cells, hair cells, which actually are attached to the membrane. And depending on the movement, they will produce the electrical impulses. They are actually sensed in the brain. But these cells act as electromechanical device. What is electromechanical device? That if you change the potential, there will be a mechanical movement. So in our ear, there is a provision that if there is a bigger sound, then what will happen? These cells will contract so that they have less contact with the diaphragm and that sound will become less or amplitude will be less. And if there is a low sound, then they will press more to the membrane so that sensitivity goes up. So this is the electromechanical movement, and this is very important in micro machines. If we want to develop micro machines, then such kind of devices are very important, and nature has already done that. So these are the cells which are attached to the membrane, and these are the electrical impulses, and this is what happens. That if there is hyperpolarization, the inside becomes more negative, then it elongates, and if it becomes more positive, then it contracts. So we should learn from that, how nature has made this device. So people are trying to make this device, not yet succeeded. Another thing is that agriculture, that in 1970, we had a great difficulty in obtaining food for all. Before that, we were eating Milo and that whatever they were actually feeding the pigs, we were eating that. पिवळी ज्वारी, लाल ज्वारी वगैरे वगैरे. पण त्याच्यानंतर हरित क्रांती झाली आणि वी हॅव बिकम सेल्फ सफिशियंट. पण पुढच्या 25 वर्षात आपली लोकसंख्या एक्सपोनेन्शियली वाढते आणि अन्नधान्य काही तेवढ्या प्रमाणात वाढत नाही. म्हणजे आपल्याला अजून गरज लागेल की याचं उत्पादन कसं वाढायचं. त्याचे अनेक उपाय लोक सांगतात अजून बरं. कारण वॉटर पाणी यांनी जेवढं वाढतं तेवढं त्याची सॅच्युरेशन झालं. त्याच्या पुढे जाऊ शकत नाही. आता आपल्याला काय करायला गेलं, वी हॅव टू डू जेनेटिक मॉडिफिकेशन ऑर वी हॅव टू फाइंड आउट सम न्यू वे. आम्ही जो प्रयोग केला होता तो असा होता की हे जे राईस सीड्स आहेत दे आर एक्सपोज टू मायक्रोग्रॅव्हिटी इन माय लॅबोरेटरी आणि मग ते शेतात आम्ही पेरले. तर त्याचं असं दिसून आलं की त्याचं उत्पादन वाढतंय. म्हणजे दे आर ॲक्च्युअली ग्रोन टॉलर अँड वी हॅव मोर प्रोडक्शन ऑर यील्ड. आणि त्याचं अनालिसिस केल्यानंतर दे आर रिच इन प्रोटीन ऑल्सो. So we have to find out such different ways which are new, which were not thought earlier. So that you have to. So you have to work with the new ideas. So cutting edge technology needs new ideas to solve the problems which are not being solved. So students should think about new ideas and they should follow them. Not only think, but you have to follow them. This kind of research I was following for last 20 years. And now Subhanshu Shukla has made some experiments in space. So those experiments were based on our experiments. So then we asked ISRO that they should share those seeds with us, which they have done. And now we are doing experiments on that. And we are helping them to establish the laboratory for this. So why this happened? Because we followed an idea which was not followed by others. And we are now getting the returns of that after 20 years. So this is very important. If you want to do cutting edge research, you must have ideas. Now you should be aware about the instruments which are available. Because you need instruments. They may not be available over here in your college, but they are available around somewhere, means in Pune, Mumbai or some other place. And many times they are available for the use, which we don't know. So you should know that what kind of instruments are required, and these instruments are advanced instruments. So this is an optical tweezer. They use laser beams to hold a cell or a particle, and then we can study the properties of that. Or if you take DNA, you can attach beads on 2 points and you can stretch it and see that how the properties of DNA change because of this tension. So there are many ways. In single molecule studies they call it. So these are the cutting edge research which is going on. See here the same thing is shown, that how you can stretch a DNA or a single molecule. See here. And the force is very less, piconewton, 10 raised to minus 12 Newton. It's a very small force which is there. Or TEM, transmission electron microscope. Normal microscope will give you resolution of few microns. But if you want to go beyond that, this light is of no use. So we use electron as a probe, because electron has a shorter wavelength, h upon me, you know that. So you can actually get a better resolution, and that is why such kind of instrument is required. It is available in Pune University. These are the photographs. Or if you want to have space studies or imitate the space environment, that kind of facility is also there in physics department. These are the laser deposition system. If you want to synthesize new materials, because if you want to break through, you will have to try different materials for different purposes. This is photovoltaic laboratory. If you want to create, say, this will be discussed in detail. I am just giving you the glimpse of that. That if you want to design and make photocells, then you need this kind of things. This scanning electron microscope, you can go to atomic level resolution with this. So this is also available in Pune University, or ICER it is there. So these are the examples of this cutting edge, which areas it is required. Discovery of most distant galaxy. You know that there is a theory called Big Bang. And what he says, that there was a mass which was concentrated and because of the pressure which was developed internally, it exploded. And that is how the world was formed. And when it was formed, some 15 billion years ago or something. But there is another theory also by Dr. Narlikar, steady state theory, which says that world was there. It has not been created through Big Bang. But there were changes which happened, and because of that, the solar systems and all this. Now, how do you prove that which is right? Big Bang is right or steady state theory is right? Right now, there are evidences which support Big Bang theory, so it is accepted. But if one day, if somebody finds out that there is a galaxy which existed 15 billion years ago, then Big Bang theory is gone. So that's why people are trying to see that which is the distant galaxy, which we can actually find out. So that is this question. Dark matter is another question. That it is said that there is a matter which we can't see. How do you see the things? We see things through probe. Now light is a probe right now. If there was no light, we can't see anything. But why can we see the object? Because light interacts with the object. It gets reflected from there. Suppose it doesn't interact, then you will not see anything. You will have no information. So dark matter is the one which is not interacting with the existing probes. It is only affected by gravitational field. But gravitational field you can't measure like that. We can't see it or make use that. Gravitational waves now people have predicted and they said that they have measured also there. But we have no detector, which can be used, to see that. So the question is that whether dark matter exists or doesn't exist. People say it exists because the speed of the outgoing galaxies, it is not as big as expected. So something is pulling it. And that's why they see that there is a dark matter. So that is another cutting area. Quantum photonic chip, quantum computing is another area. You know that if you can succeed making a quantum computer, then that will be 1,000 times more faster than the existing one. Because existing computers have reached certain limit. Because there is a requirement that the smallest element has to be of certain size. You cannot go beyond that because then it loses its semiconductor properties. So people are thinking of now quantum computer, where you can have tremendous capacity and speed is also enormous. So that is another cutting edge area. Biotechnology in medicine, of course, personalized medicine is another challenge. That now if I have a headache, I go to the shop and he gives me Anacin. If some other person goes, he will give Anacin only. But Anacin may not be suitable for both. It may be suitable for one, it may not be suitable for other. Like suppose you take Astro, then I get the allergy. Other people don't get it. So it is not suitable for me. So the question is, can we have a personalized medicine? So genome, he has already mentioned that with the help of genome, can we calculate a medicine for a particular person? So that is another challenge. Personalized gene therapy. You know that there are genetic defects which मतिमंद मुलं असतात, मला माहिती आहे. आता हे जेनेटिकली हे असतात, तर ते करेक्ट करता येतील का आपल्याला बिफोर और आफ्टर? आणि दॅट इज ऑल्सो अ बिग चॅलेंज. सो कटिंग एज रिसर्च इन दॅट इज रिक्वायर्ड. लॅब ग्रोन टिश्यूज अँड ऑर्गन, म्हणजे आता आपण आयते घेतो, आता तुम्ही म्हणता अवयव दान म्हणतो ना आपण, म्हणजे ते आयतं घेतो आपण, पण ते लॅबोरेटरीमध्ये आपल्याला हार्ट करता येईल का, पाय करता येईल का, लंग्स करता येतील का? That is also a cutting edge. AI in lab research. How to use it? How to use it effectively? That is also a big challenge. So people are working on that. Brain-computer interface, I have already said. AI in climate models. Predictions. Weather prediction is very critical. आता इंडियामध्ये वेदर प्रेडिक्शन कसं होतं की पुढच्या वर्षी ॲव्हरेज पाऊस पडेल, कुठे पडेल माहिती, किंवा सरासरीपेक्षा जास्त पडेल, किती पडेल माहित नाही, कमी पडेल असं प्रेडिक्शन. का? कारण आपल्याकडे तेवढी इन्फॉर्मेशन नाही. ते मॉडेल तयार करायचं त्याला इनॉर्मस डेटा लागतो आणि खूप पॅरामीटर असल्यामुळे ते कॉम्प्लेक्स मॉडेल तयार होतं. तर दॅट इज अ बिग चॅलेंज. तुम्ही जर ऑस्ट्रेलियात गेला तर ते म्हणतात 4:10 पाऊस पडेल, तर 4:10 बरोबर पाऊस पडतो. आता याचं कारण काय आहे की त्यांचं प्रेडिक्टेबल वेदर आहे. इंडियन वेदर इज अनप्रेडिक्टेबल वेदर. कारण आपण 3 बाजूने समुद्र आहे आणि मध्ये जे जमीन आहे तर त्याच्या इंटरफेसवर थोडा जरी प्रॉब्लेम झाला तरी सगळं बदलून जातं. त्यामुळे पाऊस येणार म्हणताना येत नाही, नाही म्हणताना येतो. याचं कारण असते. तर त्याच्यात तो एक एरिया खूप महत्वाचा आहे आणि आपल्या पिकांच्या दृष्टीने खूप महत्वाचा आहे तो रेअर अर्थ मेटल्स. अमेरिकेत सध्या कॉन्फरन्स झाली, कारण रेअर अर्थ मेटल जे आहेत ते सगळ्या इलेक्ट्रॉनिक डिव्हाइस मध्ये तुम्हाला लागतात आणि चायनाची मोनोपॉली आहे सध्या. भारतामध्ये आहेत पण आपल्याकडे एक्स्ट्रॅक्शन मेथड्स नाही आहेत सर, आणि त्याच्यामुळे आपल्याला त्यांच्यावर अवलंबून राहतात आणि चीन तो मॅनेज करतो त्याच्यावर. साधे परमनंट मॅग्नेट बनवायचे तर त्याला रेअर अर्थ लागतं आणि मग चायना म्हणतो की आम्ही देणार म्हणजे तुमची फॅक्टरी बंद झाली. तर ते खूप महत्वाचा एरिया आहे. त्यासाठी भारतीय म्हणजे आपल्या गव्हर्नमेंटनी 72,000 कोटी रुपये ठेवले त्याच्यासाठी, रिसर्चसाठी, की हाऊ टू डेव्हलप मेथड्स टू एक्स्ट्रॅक्ट अँड प्युरिफाय रेअर अर्थ. सो दॅट इज ऑल्सो अ व्हेरी इम्पॉर्टंट एरिया. सिंथेटिक मायक्रोज फॉर प्लास्टिक डिग्रेडेशन. प्लास्टिकचं एवढं हे झालंय, आपण करतो काही काही कॉलेजमध्ये लावतात, स्कीम्स लावतात, पण ऍक्च्युअल प्रॉब्लेम सिरियस होत चाललाय. आता तो आपल्या अन्नामध्ये यायला लागला, मायक्रोप्लास्टिक्स, आणि हे दुधामध्ये यायला लागलं. तर ते नष्ट करणं फार महत्वाचं आहे आणि त्यासाठी मेथड्स आपल्याला कंडिशिव्ह मेथड पाहिजेत ना. तर काही लोकांनी मायक्रो वापरायचा प्रयत्न केला पण ते काही होत नाही सक्सेसफुल. तर कॅन वी मॉडिफाय दॅट मायक्रो? जसं इन्सुलिनचं उदाहरण दिलं सरांनी की युजिंग मायक्रो फॉर इन्सुलिन प्रोडक्शन, तसं मायक्रो फॉर प्लास्टिक डिग्रेडेशन. सो दॅट इज ऑल्सो अनदर एरिया. ग्रॅव्हिटेशनल वेव्ह रिसर्च इज ऑल्सो अनदर एरिया. लायगो प्रोजेक्ट जे आहे औंढा इथे झालं, तर त्याच्यासाठी काय लागतं, असे बीम्स लागतात 1 किलोमीटर लांबचे 2 लागतात आणि मग त्याचं इंटरफिरन्स हे करतात आणि त्यात फरक किती पडतो, 10⁻21 वगैरे वगैरे. इट्स अ व्हेरी डेलिकेट आणि तर ते प्रोजेक्ट येते आपल्याकडे. आता मी तिथे पुलमन म्हणून आहे, तिथे मी स्वतः जाऊन भेट देऊन आलेलो आहे त्याला. तर दॅट इज अ व्हेरी ॲडव्हान्स काइंड ऑफ इन्स्ट्रुमेंट. सो इंडिया विल हॅव इट. सो students can think in going in such areas also, which are coming in future. Pollution control, another big problem for India. How to control pollution? Because Mumbai, Delhi, you have seen that the problem has become big. आता काही एक्झाम्पल्स तुम्हाला सांगतो. आता याच्यामध्ये काय म्हणतो, मायक्रो निडल्स फॉर पेनलेस इंजेक्शन अँड टेस्ट. आता लोकांना खूप भीती वाटते इंजेक्शनची बऱ्याच वेळा, ते टोचतं म्हणून. अँड सम पीपल आर व्हेरी सेन्सिटिव्ह टू दॅट. हे काय फार टोचत नाही पण लोकांना सेन्सिटिव्ह. तर कॅन वी हॅव निडल विच इज पेनलेस? सो पीपल आर ट्राईंग दॅट. सन पॉवर्ड केमिस्ट्री, मॅन्युफॅक्चरिंग ऑफ केमिकल्स कन्झ्युम फॉसाईल फ्युएल्स दॅट कॉन्ट्रीब्युट टू CO2 इमिशन. तर तो रिड्यूस कसा करता येईल आपल्याला, तर त्याच्यासाठी रिसर्च चालू आहे. स्पेशल कॉम्प्युटिंग. Does everything virtual reality, augmented reality apps do? Digitize objects that connect via the cloud. म्हणजे शरीरामधले सगळ्या अवयवांची तपासणी ते व्हर्च्युअली करू शकतात. तर त्या टाईपच्या मेथड्स आपल्याला डेव्हलप करता येतील का असेल. इन सिलिको मेडिसिन, कारण की मेडिसिन तयार करायला लीड मॉलिक्यूल लागतो. मग लीड मॉलिक्यूलवर मग तुम्हाला एक्सपेरिमेंट करायला लागतात. मग तो इफेक्टिव्ह आहे का नाही ते तुम्हाला नंतर कळतं. त्याच्याऐवजी तुम्ही जर इन सिलिको कॅल्क्युलेशन्स केले तर ती ऍक्टिव्ह साईट जी आहे त्याच्यामध्ये ते डॉकिंग होतंय की नाही, किती होत आहे, किती प्रमाणात होत आहे, हे तुम्हाला कॉम्प्युटरच्या सहाय्याने करता येतं आणि त्याच्यामुळे बराचसा खर्च वाचतो आणि वेळही वाचतो. एक मेडिसिन बाजारात आणण्यासाठी 10 वर्ष लागतात आणि बिलियन्स ऑफ डॉलर्स खर्च होतात त्यावेळेस एक औषध बाजारात येतं. त्यामुळे तुम्हाला जर हे करता आलं तर त्याच्यापासून खूप फायदा होणार. डिजिटल मेडिसिन ऍप्स नाव dental medicine and physical disorders. डिटेक्ट करू शकता आपण म्हणजे कॉम्प्युटरच्या सहाय्याने आता काही ट्रीटमेंट पण चालू झालं. चायनामध्ये एक हॉस्पिटल आहे, तिथे सगळे रोबोट काम करतात म्हणे. तुम्ही दवाखान्यात जाण्यापासून तुमची ट्रीटमेंट होईपर्यंत तुम्ही किती विश्वास ठेवायचा माहिती नाही, पण तिथे करतात, सगळे रोबोट काम करतात. इलेक्ट्रिक एव्हिएशन मध्ये सुद्धा आपल्याला बरेचसे ब्रेक थ्रूज हवेत. याच्यामध्ये लोअर कार्बन सिमेंट हे जाणं आपल्याला फार सोपं वाटतं, पण इट इज कॉझिंग लॉट ऑफ हेवॉक इन सिटीज. क्वांटम सेन्सिंग, ग्रीन हायड्रोजन. आता हे याची आयडिया काय म्हणजे का, की हायड्रोजन प्रोडक्शन आणि ऑफकोर्स इट स्टोरेज अँड ट्रान्सपोर्ट, ऑल दीज आर व्हेरी क्रिटिकल. याच्यामध्ये काय केलं लोकांनी, अल्गी जी असते, तर अल्गी कॅरीज आउट फोटोसिंथेसिस. पण इफ यू डिप्राइव्ह इट फ्रॉम सल्फर, then what happens, instead of photochemical reaction, hydrogen production increases, and then you can collect that hydrogen and use it for as a fuel. आणि त्याच्यामुळे काय होतं की बिकॉज फोटोसिंथेसिस रिड्यूस, that algae becomes weak, so you again supply sulfur, so again photochemical reaction starts and it becomes strong, again use it. So now there are questions of efficiency, that how much is the efficiency. So people are trying to genetically modify these algae so that they will give better production. So hydrogen fuel is another area where people are trying to do research which will help us to use it as a fuel, because that is very essential. कारण pollution होणार नाही ना. Whole genome synthesis is another thing. Researchers use software to design genetic sequences that they introduce into a microbe, thereby reprogramming it. So artificially तुम्ही करू शकता structures which can be active. Active असतीलच असं नाही आहे, but then you can try it by introducing in the microbes. आता ही some of the examples are magnetic bacteria. Yeah. तर तुम्ही कसं करू शकता, म्हणजे हायर एज्युकेशन सिस्टीम, हाऊ कॅन दे अडॉप्ट ऑल दिस काइंड ऑफ थिंग्स. तर त्याच्यामध्ये बॅलन्स पाहिजे, कोअर सब्जेक्ट, अप्लाइड, इंटरडिसिप्लिनरी, मल्टीडिसिप्लिनरी. कोअर मध्ये कमी व्हायला नको, पण तुम्हाला स्किल्स मिळाले पाहिजे. आता स्किल मध्ये दोन प्रकार आहेत, एक तुमच्या विषयाशी रिलेटेड आहे, दुसरा तुमचा आउटसाइड आहे. आता समजा तुम्हाला ड्रामा म्हणून स्किल घ्यायचं, तर ते आउटसाइड तुमच्या होईल, तुम्ही जर फिजिक्सचे विद्यार्थी असाल तर, किंवा केमिस्ट्रीचे असाल तर. पण फिजिक्सच्या रिलेटेड तुम्हाला जर एखादा कोर्स घ्यायचा असेल जो स्किल ओरिएंटेड आहे, तर तो तुम्हाला स्ट्रेंथन करेल इकडे. आणि हे होत असताना तुम्ही एक गोष्ट लक्षात ठेवली पाहिजे की बेसिक प्रिन्सिपल्स ऑफ द सब्जेक्ट शुड नॉट बी कॉम्प्रोमाइज. कन्सेप्च्युअल लर्निंग त्याच्यासाठी खूप इसेन्शियल आहे. So you will have to orient yourself to conceptual learning rather than rote learning. कारण rote learning करून तुम्हाला रिसर्च मध्ये कुठे जाता येणार नाही, आणि कटिंग एज मध्ये तर नाहीच नाही. So these higher education systems will have to orient themselves to prepare the new generation to contribute in cutting edge research. आणि त्याची सुरुवात इथे होते कॉलेजमध्ये, आणि म्हणून आय कॉंग्रॅच्युलेट प्रिन्सिपल and his team for organizing a 2-day conference on this subject and making it available to students. That is very important. So I am sure you will learn many things, and it will expose you to the recent research which is going on, also the problems to be undertaken, and you should ask questions. You should ask a lot of questions to the presenter, get into discussion after lecture also, so that you are clear your own doubts. Don't keep doubts in mind. Say, speak, interact. Maybe somebody will laugh at you, don't bother. Because that is a gain for you. Because you realize that you are not correct. And that is the first step to learn. So with this, I thank Principal Dr. Sarode, his colleagues, and I am very happy to share dais with Dr. Maske, Dr. Dinanath Patil. It is always homecoming because this is Rai Shikshan Samstha's college, and I had been student of this Samstha in my school days. And as I said, I would have not been here and speaking to you if Karunarao Patel has not taken up that task. So thank you very much.